Okay, so I was really, really big on this. When I went for my training last spring, they had a panel of kids that were current students at IU that had taken ACP chemistry in high school. And they had them come in and talk to us about what they wish they would have done in high school and the things that they would tell the high school students. So the suggestions for learning, and one of the things that they talked about was that to promote retention or to be confident when you get into the test is overlearning. So repeated practice. That I'm sure sometimes when you get into mastering chemistry, you're like, all right, I've already done this question like 3 times. Why am I doing it again? This is why. Repeated practice. Make sure you know what you're doing. Have you guys gotten into your mastering chemistry? How is it? I haven't looked at it.
We do both of them.
Yeah.
Wait, it took like the first 4 questions on both of them are the same.
Okay. Oh, well, there you go.
The first
Perfect.
half is always stupid.
Awesome. Okay, good. The spacing effect. So that's talking about not cramming every single thing into your brain the day before a test or thinking that you're going to be able to. So taking some space. One of the things that will help you be successful in ACP Chem, and this is one reason why I had you read the chapter and take notes. Now, hopefully you didn't do it this morning, but you read the chapter and you took notes and you slept. Now you're going to come in and we're going to talk about that stuff that you guys took notes on, okay? We're going to give it a little space. Then tomorrow, we're going to come back again and we're going to talk about it again and we're going to revisit it. One of the ways to be successful is to give your brain some space. You need time. It needs time to like file that stuff away. Your little filer only works at a certain pace, and he can't go any faster than the pace you got. So you got to give him some time to get his work done and put the stuff where it needs to be so you learn it. Effort, hard work pays off. I think it's very evident. I can almost always be like, he's trying. Nope, she's not trying. Sorry about that. It's pretty obvious. Make and use flashcards for facts and fundamentals if that's something that works for you. Lily Beller told me that the online flashcard thing, I can't remember what it's called, isn't free anymore. Quizlet.
No.
Only like the first 21 or something. I thought that's what she told me. Maybe I'm wrong. You guys let me know. I personally like actual flashcards, so that's fine. The other last one is rest and healthy choices. I know you guys have a lot going on. I get that, but you do at some point need to rest. Please don't come in the day before a test and be like, I stayed up all night and I had energy drink, whatever you guys are drinking nowadays, before I came in and I am ready to go and your hands are like, yeah, that's not what we're looking for, okay? So make sure that you're like actually eating and resting and getting your stuff. And I know a lot of you are playing sports, you're doing all kinds of things, and I get that, but try to make good choices. All right, so enough preaching about how to handle yourself. Let's talk about chemistry. So what is chemistry? Chemistry is considered a central science. What do we mean by that? It is one of the very core sciences that we have. It's essential for meeting our basic needs of food, clothing, shelter, energy, clean air, water, soil, all of these things. So I didn't tell my other ACP classes because my husband wasn't doing this, but my husband took a job about 14, 15 months ago, and his new job is so cool. So he has this job, he works in ag, but he has this job where they have a nanoparticle. So this particle was originally used in chemotherapy. When my dad was diagnosed with cancer, let's see, when was this in 2004, 2006, 2007, 2005. In 2005, they just come out with this brand new treatment. So the idea is there's this nanoparticle, and what you can do is load the drug onto the nanoparticle. And I'm not sure how much you know about cells, but cells can only move, typically, they only move like one molecule at a time across the cell membrane. This nanoparticle, they load the meds onto, and then it's like taking a bus across the cell membrane. So they can all go in at once into the certain cells. And they also have directions to certain cells. So these nanoparticles are like, they are directed directly at cancer cells. So the only cells that let them in are the cancer cells. So they were loading the drugs directly into the cells to kill them. But anyway, back to Mike. So Mike's job is fertilizer. He works for, well, he doesn't work for a liquid fertilizer company before, but he was before. So what they're doing, which is so cool, is they can take that same nanoparticle that they're using in chemotherapy, and they can load it with nutrients for plants. So if it needs potassium, if it needs nitrogen, whatever the plants need that there is not enough of in the soil, they can load it onto that nanoparticle. They spray it on the plants, and then it goes directly into the plant so they have the nutrients. So it's pretty awesome. He's like, can you explain this to me? They got, and I'm like, yeah. He doesn't like that part of it, but I do. I think it's pretty cool. So that being said, there's a wide variety of careers that are interesting, rewarding. Another really cool thing that has to do with ag that I just discovered was he's working with this company that grows bacteria. And they call them bacilla. It's the type of bacteria they are. They have like 40,000 different types of bacilla. So if you say, hey, I need some drought resistance, they're like, no problem. They send it to you and you spray it onto your crops, and those bacteria will help it be like drought resistant. Or, hey, I've got pneumonia going through a pig barn. They send them a sample of what it is, and they send back bacteria, and you feed it or put it in the water, and then it can work so that you don't have to get antibiotics. So it's pretty awesome. Anyway, chemistry. There's a huge wide variety of different things. Those happen to be 2 ag things that I have come across in the last couple of years. It's helpful in the advanced study of biochemistry. Biochemistry is chemistry that has to do with living things. Endocrinology, that is the chemistry of our bodies. So like all of the hormones, the adrenaline, the dopamine, all of the different chemicals that give you the feelings, the ability for your body to work. Physiology, microbiology, and pharmacology. This obviously is a huge one. This is a huge industry right now, being able to do different drugs. So it's an excellent major for students planning careers in health professions, medicine, pharmacy, dentistry, optometry, veterinary medicine. There's all kinds of applications for chemistry. So chemistry in action. Let's talk about something that we have done recently. So let's talk about the anti-cancer drug. It's called Taxol. In the 1950s, the National Cancer Institute. If you got cancer in 1950, it was a death sentence. There was nothing they could do. Cancer had been around, but it wasn't diagnosed much before that time. We suddenly realized, oh my gosh, we have something that's happening to the human body. We're going to call it cancer. It's really just like the overgrowth of cells. They discover that this is a problem, right? And in the 1950s, the National Cancer Institute was like, there's got to be something that can help us. So the first thing they did was they started screening plants. Anybody who knows anything about human history knows that even before we had technology and we were mass producing drugs, there were things that people could do with plants to help alleviate or relieve symptoms, right? I mean, the Native American Indians were chewing willow bark because it has aspirin in the bark, for pain. There's all kinds of plant applications. So in the 1950s, the National Cancer Institute was like, we've got to find something. Let's start. The first thing we can do is start screening plants. We're going to look for something that will slow this growth down. And the result was they found that the Pacific yew, which is a tree, the bark, if you extract that, it inhibits tumor growth. So immediately they're like, oh my gosh, we found something sweet. So in 1969, they isolated the active chemical, which they called paclitaxel. And in 1971, they determined its structure. In 1983, they started human trials. Notice, 1950, they start looking. 1969, they finally are like, okay, we know what the chemical is. Then they have to find the structure. Because just because we know it's C47H51 N014, here's the deal. The way chemistry works is how those molecules are arranged matter. So the arrangement that they are in changes their performance or the way they act. You can have they can have the exact same chemical formula and a different arrangement and be two totally different things. It would be like if you said, okay, so a human has a torso, 2 arms, 2 legs, and a head, but you don't know how to put it together. And the first thing you do is like put the head on the bottom, and you're like, that doesn't work, you know? So then you've got an arm and a leg. You don't know exactly how it's put together. So you have to put it together correctly to make it work correctly. So it took them 2 years just to determine its structure. Like, how are these molecules arranged that it works? And then 12 more years before we get to human clinical trials. Another 9 years, the FDA finally approves this chemical for breast cancer. Here's the problem. This bark only contains 0.01% of Taxol. It's a poor drug source. If you take the bark off, it kills the tree. It doesn't like remake it. So there are only 2,000 to 3,000 mature yew trees. That's how many we need to get a kilogram of Taxol. That's not going to work. That's not effective. They don't grow fast enough. This is what the chemical structure looks like. If you were wondering why it took them 2 whole years to figure it out, this is why. This is what it looks like. So that meant you needed 6 100-year-old trees to treat a patient. That's a lot of trees, and we don't have time to grow them to 100 years old. So what do? We need to find another source. And eventually we realized that there's a similar chemical in the English yew in the needles, and it's common, it's fast growing. They can take the needles off without killing the tree, and then they can make this paclitaxel, which is the little thing. It's this little piece right here in the pocket, and it hinders cell division. So when you give someone who has cancer this drug, what it's doing is it's hindering that cancer from growing. It's making it so that it doesn't divide. That's all cancer is. Cancer is just an out of control cell that doesn't have a stop on it. And depending on how fast it replicates itself, that's how fast the cancer is acting. So when you hear somebody say, oh, that's a super aggressive type of cancer, that just means those cells they're replicating themselves quickly. Also, the word cancer, sometimes you hear like you have a benign tumor. That type of tumor means that there's no cells that break off and move to other parts of your body. The definition of cancer is that not only do you have uncontrolled cell growth, but you have uncontrolled cell growth that is breaking off and has the ability to travel to other parts of the body. So when you say, oh, the cancer has spread, that means that those cancer cells have broken off that original place and they have gone to different places in the body. Okay, so that's the basic idea behind why we're studying chemistry. Lots of different things. How science is done. Here we go on this thing that you've learned every year since you started learning science. Right? We ask a question, we do the background research, we make a guess, we construct a hypothesis, we test it. Is it working? Yes or no. If it's yes, you analyze the data and draw conclusions, and then do your results align with your hypothesis? Yes or no. If they don't, you go back, you fix your hypothesis, and you do it all again. If the answer is your procedure working? No. You troubleshoot your procedure, you go back, you check the setup, and you do it again. If your results do align with your hypothesis, here's a big one down here at the bottom that I don't think we hit enough. Communicate results. In the actual scientific community, if someone's like, oh my gosh, I discovered the cure for whatever, diabetes, really, give it to me, let me do it. You have to be able to hand over your research, and someone else has to be able to replicate it. And it's not one person. The way that science is working right now is we have hundreds of thousands of labs all over the world, And when someone comes up with something brand new, some of those labs are committed to only testing other people's research. So they'll take that new process and they'll be like, let me try it. Now, there are a few lines that have been drawn in the sand. Number one, and this line has already been crossed, so I don't know exactly what we're going to do with that, but human cloning is a line that scientists have drawn in the sand. The world scientific community has agreed that human cloning is off limits. We're not doing that. That being said, about 4 years ago, a Chinese scientist cloned a human baby. It was a girl, and they are alive to the best of my knowledge. The scientist is not. The communist country of China executed him because it was like he just wasn't supposed to be doing that. So that's pretty much the line drawn in the sand for the world scientific community. There aren't a lot of other lines. There are like nuclear weapon lines that are supposed to be drawn, which are real fuzzy at this point. And lots of different countries are experimenting with lots of different nuclear. It's hard to say you're not allowed to have a nuclear bomb, but it's okay if you want to work with nuclear energy. So there's a lot of interesting things. I do know that one of the other worldwide laws that we have agreed to is that we are not going to have a nuclear power plant within 5 kilometers of the ocean because when you do nuclear power, you need a lot of water because they use it for cooling. And the ocean is a very convenient source of water, but we also have no control over the ocean, and it tends to kind of do what it wants. So what we don't want to do is have a nuclear power plant destroyed by the ocean and take all of that nuclear material with it, which I've already had happen, but we learned our lesson. Yes.
Do we know anything about the information, if information was retained by the cloning code?
By the what?
The cloning?
Oh yeah, the Chinese government had all that and they shared it all out.
No, I mean like the actual baby being cloned. Do we know if it retained anything it knew previously to being cloned? Did the clone also know that information?
That is not
That doesn't.
That's what I'm asking.
That's not a thing. They cloned the embryo.
Gotcha.
It wasn't like it was you.
Yeah.
So they'll look the same probably if they're raised in the same environment?
They were 2 different surrogate mothers. So already there should be differences because of the birth or the what's that? So the thing about genetics is that you have the exact same genes, but genes are turned off and turned on and affected by the environment. So even when you have the exact same genes, you don't always have the exact same person. I mean, identical twins are a great example of that. Sometimes you'll have a twin that's taller than the other, or sometimes you'll have a twin, maybe one twin doesn't like to eat as well as the other one, or I mean, there's all different kinds of things that can affect. Yeah, even trauma can affect the psychological of a twin and make them like different things, or yeah, they typically aren't exactly the same. So there's like genes and and then there's gene expression, and the environment works on the gene expression part of what's going on. Anybody else? So I've been working really hard on this biology class. Here's a great example of this that I came across. I like politics, so I don't ever listen to anything political because it just makes me mad. But my husband does like politics, and he shared this podcast with me that was so amazing. So this guy was doing this research, and the research is on gender equality. So the differences between men and women, and different countries that have more gender equality, and countries that have less gender equality. Like one of the examples was Norway, that has a very high gender equality. Like men and women are treated very equally in that type of country. And then there are the more patriarchal countries where the men are dominant and the women are submissive, that type of thing. So the research was, what is changing about men and women in that country? And here is the crazy thing that's so cool. So in the countries where men and women are being treated the same, like in the countries where they're more equitable, the genes that are being turned on are those that are making people more masculine and more feminine. So the more equal they're being treated, the more the genetics is coming out for the masculine and feminine traits. It's turning on these genes that are making them more prevalent, which is the exact opposite of what you would think would happen. But he had like 100,000 data points about how all of this, it was crazy. You have to look it up sometime. But anyway, gene expression.
Did it work the other way around?
Yeah.
So everyone would be in a cycle of going inwards and then back out, and then inwards and back
Yeah,
out.
depending on your social. Isn't that cool? It's so cool. Anyway, I thought it was awesome. Okay, real quick. Science is done. Observations. Oh, I gotta grab my paper. It's been a while since I've read this. This is it. Observations are made, and a hypothesis is tested. So you make these observations, and then based on the observations, you make a hypothesis. What is happening? So you make your observations, and then you test a hypothesis. And it's a tentative idea to explain your observations. So if I said, okay, we have more guys than girls in this class, that's an observation. You can make a hypothesis based on that. Your hypothesis could be more guys like chemistry, or it works in more people's schedules, or whatever your hypothesis could be, and then you can test it. You have questions on any of this? Okay, we're going to stop here today. We will pick this up tomorrow and probably do we have group work in this class, in this chapter? I can't remember.